afternoon, my name is Insun and our team member is Onsun Park, and title of my talk is a source code debugging learning platform, LLM-based problem bank and lag-based chatbot. Let's begin with the background. Existing IT problem banking system have three issues. First is an algorithm-centric design that leaves little room for repeated debugging practice. Second is answer equivalence grading with little actionable feedback. And last is growing dependence on AI, which stirs coding competence. This observation motivates our work. This part is our core objective, and this is our expected effect. Let's begin with the research content. First, research content is LLM-based problem generation. Debugging scenarios are very diverse. We organize common real-world failures into 7 core types, for example, syntax, logic, API compatibility, concurrency, and DevOps-related issues. In total, we define 7 categories and 21 subtypes. For example, async is divided with deadlocks and missing logs, and syntax is divided with undefined variables and parse errors. Beyond Python and JavaScript, we include Dockerfile, YAML, and CMake to reflect DevOps context and industry realism. Generation procedure. With the Bench Builder GPT prompt, we created easy, medium, hard items and structured each as an A-field JSON, like language, prompt, topic, subtypes, buggy code, fix explanation. Code is kept at 40 lines and explanation at 120 words to support repeated practice. To remove near duplicate, we embedded items with E5 large V2 model and compute cosine similarity. Pairs with similarity over 85% are prone to ensure uniqueness. For quality control, we use a chain of thought prompting template that requires criterion by criterion reasoning before scoring. This reduces impulsive or biased judgment and improves consistency. We score 6 criteria like clarity, realism, correctness, minimality, safety, explanation. And based on this, we score 1 to 5 scale and discard low scoring items. Difficulty policy. Easy emphasize concept learning and clarity. Medium level stress efficiency and correctness of fix. Hard focus on system level impact and stability. Each level has a distinct learning target. We then applied ensemble validation. Items must score over 4 under both COT and non-COT evaluation. And about 200 problem-generated items, 4068 remain, making a reliable bank. The second research context is LLM scoring logic. Why this approach? Because it handles tasks without a single canonical answer, with overcoming limits of text similarity metrics. Second is it returns evidence back and feedback, guiding improvement. And last is it can also support large-scale consistent assessment. Our internal study showed 80% agreement with expert grading. In this part, we also set 5 criteria, like this, here. Executable correctness, functional equivalence, structure similarity, and fixed alignment, we scored on 1 to 0 scale. This moves beyond pass and fail to judge whether the change is meaningful and logically resolves the bug, turning the judge into a reasoning expansion tool. The third research content is lag-based chatbot. First part is data set construction. LLM generate fluent text but often lack citation, so we therefore build sentence-level evidence so response explain why a fix is warranted, like perform evidence-based reasoning. Sources are limited, official 50 debugging papers. Preprocessing has 5 steps: raw text extraction, boundary footnote cleanup, debugging sentence filtering, topic labeling, removal of answer leading phrase. The remaining evidence supports reasoning, not final answer. Evaluation design. Using the same question set, we compare a lag model against a non-lag model. If lag wins, its contribution is sustained. Questions go beyond syntax to include root cause tracing, activity analysis, and symbolic execution, reflecting real development sentence scenario, like this. Our evaluation method is first, generate answer from lag and non-lag, and second, score with the LLM judge on 3 axes: intent alignment, specificity and feasibility, and evidence use. And last, compare to 1 to 5 and pick the winner. Result is like this, here. Lag is 30.76, but long lag is 30.16. Win rate is 71, and real constant p-value is like this. So latency increase, but which is acceptable given the quality gain. Guardrails. We detect over 20 Korean English patterns such as give me the answer accordingly and switch to hint-only mode. The system informs users that solution will not be provided and instead of offers stepwise hints, reducing answer outsourcing and prompting reasoning. Our service architecture is like this. At the center is the BugGym server, and GPT-4.0 generates problems. Claude validates and scores, and Best API plus LinkedIn's the paper-grounded lag and rejects space guardrails block direct answer prompts. The service is publicly available. You can find it by search BugGym on Google or via the QR code. Conclusion. We address the algorithm-centric implementation by providing a debugging problem back with COT-based quality control and deduplication, enabling repeated practice. And also, we overcome feedback scarcity by the LLM judge that yields concrete actionable guidance. And we also mitigate AI dependence by combining lag with guardrails, replacing direct answer with evidence and hints to encourage analysis and solution seeking. To sum up, the integration of automated problem generation, multi-phase evaluation, and evidence-guided coaching suggests a new paradigm for debugging education. Next is our simulation part. Let's start it.
This is our website, BugGym. We can searching typing the BugGym on the Google website. This is our service, and we can start. And this is our problem list, and this is the filter, and here is the categories, and here is the type of language, and here's the subtype about the categories. And you can find many problems. Okay, here the category is the thing and the subtype is the missing rocks. And here is the problem explanation. And here is the industrial example. And this is the error code. And this is the user typing code. But first of all, we started with the error code. Okay, so here we got the score 12, and this is the feedback of our code. And this is the our chatbot. First, we started with the examples. And actually, we serve the three models chatbots with the reg or non-regs and the DeepSeek AI models. And here, this button is the include or not the problem code. And the chatbot gives the hint about how to solve this problem. And if the user want to get the real answer code, the chatbot system guardrail is the activate. And the guardrail didn't give the answer code, and actually give them more hint about how to solve these problems. This is the answer code about these problems. We got the 100% point, and this is the feedback about our point. And this is the note user can write about these problems. And if you generate the note, this note is saved automatically with the error code and the answer code. And this yellow line display the how to change the code. This is the feedback about the user writing code, and gives some similar problems. And user can download this note by PDF. Okay, like this.
This is our simulation, and thank you for listening our presentation.